Okay, yes. Hi, everyone. Good morning, good evening, good afternoon. I'm Bharat Raj. We are team number 2. We are working towards prevention of deforestation. Our team consists of me, Bharat Raj. Next, we have Genevieve, Sylvan Praman, William Van de Winton, Jennifer Steffi, and Ramkumar Sakibal. Bharat Raj, that is me. I'm a 24-year-old data science enthusiast, currently a student at the University of Groningen in the Netherlands. I'm doing my master's in AI. And we have Genevieve Berold. She's a very creative person with a professional experience of 8 years in finance and administration. She's currently joining us from South Africa and has been a very active person in our team meetings. And next, we have Sylvan Brahman. He's a software engineer at Allseas. He transitioned from mechanical engineering to software and is very happy exploring new domains in machine learning. Sil is joining us from the Netherlands. And we have William Van de Winton. He's joining us from Belgium and has transitioned to data science from the last 1 year after having 7 years of working experience as a finance project manager. He also has a master's in environmental management. Next, we have Jennifer Steffi. She's joining us from the US, and she's a senior product manager for a large finance company. She has an experience in scaling up startups in the US. And we have Ramkumar. He's a solutions architect for TCS with a very good experience on autonomous vehicles and holds a master's in vehicle engineering from TU Delft. So our goal for this competition is to track protective forest areas and identify illegal mining and logging over a period of 10 years until now. So what we want to do is we want to carry out the project in 2 phases. First is identification of deforestation based on satellite images. And based on that region, we want to get the data from the state or country and try to identify how much of it was legally deforested and how much of it was illegally deforested. So the current state of the art is something called as Global Forest Watch. So it is an interactive dashboard which consists for the whole world, and they show how forests have grown or have been deforested over the last 10 to 15 years. And a big advantage is because it is highly customizable. You can zoom in, zoom out. It has a lot of widgets. However, it lacks the identification of how much of this land was illegally deforested. We have another approach that's called MAP. It shows real-time logging detection. So it shows in real time how forests have been deforested and triggers alerts to the respective authorities. However, it needs high-resolution satellite images, which is not easily available. So we are still trying to identify more current state-of-the-art projects and to see how our project is aligned along with that. Our actions for this week has been to find more current state-of-the-art projects. Next, to identify potential data sources. So to identify data sources, the only thing challenging is how the countries have addressed the protective zones of the land and how they change over every year, because every year the state laws and countries demarcate the forest area and it changes over a period of time. So this has been a very crucial data which we have to find. And next, after identification of the data, we want to chart out the most feasible geographical area to implement our project. Thank you.
All right, thank you, Bharat. I think you guys have a really cool idea. Is there anyone who would like to comment or ask a question about this presentation or idea? All right, this is pretty clear. Bharat, is there anything you would like to ask to the people in the group? Something you didn't work out so well yet?
We are still trying to find the current state of the art. So if anyone else is working on forest-related projects, and if they come across anything similar to this, I'd really appreciate if you can just drop us a text about what the article is or what the project is about.
All right, I see a question in the chat. Is there a specific region you guys are focusing on, or will it be at global scale?
So, like I told you, it will depend on the kind of data we get. So satellite images are available. However, the demarcation of the legality and illegality of the forest which has been deforested is a very gray area. So not every country tracks how much of the land is protected and how much of it is unprotected. So once we identify the data, we will try to narrow down on the geographical area.
All right, cool.
Lo schedino vedrei la del fare sto giallo.
Sorry? Barrett, can you stop sharing your screen?
Yeah.
Okay, we're gonna move on to the second group, the topic air quality. Who will be presenting for them? Let's see. I believe Hannah is the task manager for air quality. I don't see her present today. Is there anyone else from that group that would like to present their IDs? Okay, we'll get back to this. Next group would be carbon biomass estimation. Let's see. Who was the leader there? Krishna, do it. This is getting awkward. Okay. Next up, the deforestation group. I believe we do have a lot of people from that group here today. Oh, sorry. We already had the deforestation group. I was talking about the wildfire group.
Yes, good evening, everyone.
Ah.
Anton here. I'm very impressed with the presentation that was just given. We aren't quite that far yet. So we had our first meeting yesterday. Our group consists of 2 people from India, Shri and Shyam. They both have a background in deep learning and also automotive. I'm not sure if we're going to use their background very much on the wildfire stuff, but we also have Jitse. He has done something during his graduation project, as far as I understood, with wildfires and looking at satellite images for vegetation. And well, his knowledge was very welcome yesterday in our brainstorm. And we have Helder, and he's a 19-year-old student from the industrial design. So he's also very capable of making the video that we intend to do. So that's good news. And we had a brainstorm yesterday evening only, so I wasn't able to make any slides due to a very full calendar today. But the idea, well, we were looking at some options. The one that I think is most interesting for us is to look at wildfires this year in Greece, in particular, and see what we can derive from that fires, and see if we can also do something about, looking about at the increase of these kind of fires and the impact of that in the future. And the worry is that I'm not sure if we can, let's say, address that fire to climate change, right? So it can also be, of course, a different reason. So that's something we need to research further, if we can, basically make such an assumption that these fires are actually caused by climate change or that kind of factors. And there must be some research on it, but well, we'll have to look into that. That's where we currently are, and we have our project meetings on Thursday. So coming Thursday, we're going to give it another shot to dive deeper.
All right. Good to hear that you started off good already, and you have your meeting to get even further on that.
Yep.
Great. Okay. So let's head on to the next group, the Dying Rivers group. I believe Kamal is the presenter of this group.
He's here, but he also seems frozen.
Oh, wait.
Stage freeze.
Yeah, I know.
It happens.
All right, let's see if Kamal can reconnect. Oh. Otherwise, we'll carry on with floods for now, and then we come back to Kamal. So for floods, we have no task manager yet, but is there anyone who would like to present for their group?
Hello, I'm Lam. Can you hear me?
Hi, Lam. Yeah, loud and clear. Go ahead.
Okay, let me share screen. Can you see my screen?
Yes, we see it.
Okay. In my group we have 5 members. Yep. And I maybe we don't have a group manager, but we work together and come out the idea. Yep. And maybe today's I will make presentations for our group, but maybe for next presentation another member will be in charge. Yeah. Okay. About agendas, we have 2 agendas or state of the art, case study approach. Yep. For state of the art, firstly, I just focus on the public data sets because for the public data set, we easy to compare the performance and easy to compare the techniques. Before 2015 and after 2015, there's we can see that flood detections has drawn much attention after 2015. It's proved by a lot of the data sets are published, such as it's a very popular Sentinel-1 tools, PluteNet, and some other data sets. Yep, and almost data sets from the satellite or from a UAV. For the techniques, before 2015, maybe the machine learning, traditional machine learning like Bayesian network, Markov chains, or rule-based classification are popular. But after 2015, is deep learning make use. Yep, that's I mean that's so we have more data, much data, and almost data is image based. We also have the text data. Or another type of data, but the image-based data is dominant. And the state-of-the-art technique is deep learning by approach, and CNNs are maybe GAN supervised machine combined with the boost, but actually the CNN and RNN is dominant. Yep, and I marked the number 1, 2, 3, 4 here. That is for the paper here, so people can check the paper and check the techniques used in this paper, and that's the name of the paper. Yeah, and for the case study approach, our group proposed to choose a PluteNet datasets because that's a public datasets, and let's see the image-based datasets. And in this task, we have 3. In this dataset, challenge is proposed 3 tasks: classification, segmentation, and VQA. In detail, we have the data set like this. Yep, real image and graph tools and queer pair. And that's the table on the right hand side is summarize the image and instant in the data sets. That's the data sets link for the data link paper for the data sets on the bottom. Yep, and for the case study approach, we propose to use a PluteNet datasets for case study for our group, and maybe we just focus on task 1 or task 2, not focus on task 3, because task 1 and task 2 is familiar with everybody. For task one, that's the classifications and use basically the baseline you CNN based approach, inception nest or rest nest or inception week. Yep. And the segmentation and the task two, there is segmentation. Yep. Yep, and that's it. The paper link for the Plutnet, the GitHub to download the datasets, and some GitHub repo for exploring the datasets. There's an available code network for task one, task two. I have not found GitHub for task three now. And I can conclude that if we propose this case study, this data set for case studies, so we have to use a deep learning techniques, and maybe we could use image processing techniques. And the matrix for classification task one is the accuracy in F score, and the matrix for task two is the IOU. Yeah, that's all for our group. Yeah.
All right, thank you, Lam. I see in the chat that Nicholas also shared an article about flood mapping. I think it's very interesting for you to check out. So
One
yeah.
short question, Lam, can you share these slides in the main channel? I'd like to have a look at some of the resources you've linked. Might be good for other groups if they
yes,
have.
actually, I said this slide in just our group channels. Okay, I will share it on the main channel. Yeah.
Yeah, thanks.
Yeah.
Okay, can you stop sharing your screen? Thank you. Thanks for the presentation, Lam. And now we have the room for Kamal and the dying rivers.
Hello, guys. Thank you very much. Let me just proceed by sharing my screen. Can you see my screen?
Yes, we see it.
Okay. So let me start by, first of all, introducing the team. So we have on board Harsh Shukla from India. He works in MicroStrategy, and he has experience dealing with satellite data and GIS data. We have also Ingrid Harga. She's from Croatia. She is a PhD researcher in both computer vision and natural language processing applications. We've got Tim Ufer also. He's from Germany, and he received his education in AI here in Netherlands. And myself, Kamal, I also studied here in the Netherlands, data science in Tilburg. And we have Kumar Barik. He's not actually quite active with us. We haven't got much connected in the past days. Perhaps later we could connect with him. So let us proceed with our the formulation of our research question, that what we are aspiring to do, what we hope to achieve. So the idea that we want to do is to study a river segment that has dams upstream, and we try to come up with a model that can relate the change in what is called the discharge level, that is the water flow in the river before and after the damming. What is meant by discharge is just the measurement of the amount of the volume of water that flows through a river section per second. So this is a good indicator of how much water we have flowing in a specific river. So this is phase one of the project. We hope that we can extend this to actually also model the change of vegetation or the agriculture land around a certain river based on the discharge rate, the amount of water flowing within the river. And such problem can, actually, it's a good example of how the environment is impacted by human behavior. And this is the specific case of damming, building dams on rivers. And this is a worldwide, sort of a worldwide problem now between China and India. You have a dispute over a damming policy. Iraq, Turkey, Syria also having the same problem. Egypt, Ethiopia, they have also the same problem. So there is a little bit of a worldwide impact by studying this specific issue. So let us see what has already been done in this subject. So, well, before delving in the application of AI or even remote sensing, very quickly, we'd like to present how actually river flow is modeled nowadays in the traditional sense. So, well, we have an on-site measurement that tried to measure the river width, the surface elevation of water called the stage height, and the river velocity, and also river depth. And we have like analytical models that already can correlate each of these metrics, the width, the depth, the velocity of water, with the discharge rate, the amount of water that is flowing in a river. And this is modeled through also measuring a set of constants that facilitate or we can infer from it a certain river, but a certain curve that is specific to each and every river that helps to measure the discharge or the water flow within this river. So this is kind of measured also empirically, this relationship between, for example, the amount of the surface elevation of water in a river and the water flow. So each river has this specific curve that is inferred empirically. Well, there has been also the application of remote sensing satellite data, but not specifically coupled with AI. So what people are doing is through remote sensing, through imagery, satellite imagery, they can infer river width and surface water elevation and also the slope, but not particularly river depth. There has been like reports that gauging river depth through satellite imagery is quite problematic. But through width and surface elevation and slope, they can plug these metrics that inferred from image data into some sort of an analytical solution, a solution like Manning equation or hydraulic geometry laws, and they can infer then what is the amount of water that is flowing into a river. So it's sort of an indirect way between satellite data and the amount of water that is flowing within the river. There has been also another method of doing so, applying AI, but not on satellite imagery. So have seen that we have satellite imagery, but with no AI, just the application of analytical solutions. Here, we see the application of AI, but mainly with synthetic data, without the use of satellite imagery. People refer to simulation software. The simulation gives them imagery that describes the river flow, the roughness, the simulation of the rainfall, simulation of the runoff, which is the dispersion of water after a rainflow. And these simulated imagery are then used to train AI and deep learning, machine learning and deep learning models. These models can then predict what is the discharge rate, what is the depth, or any other key value of interest. Well, our solution that we were trying to develop here is to use remote sensing, satellite imagery, plus AI. This has not yet mainly done as a direct way to measure river flow, the flow of water within a river through satellite imagery in a direct sense. So we have been thinking of a solution that goes as follows. Let's say that we have a satellite image of a river at point T. Then we can refer to a database that has the water flow, the amount of water in this river at the specific point of time T. So we can couple a satellite image with a given discharge rate or a water flow rate. Then our model would segment the river from the satellite imagery, and we can train the model to learn the mapping between the satellite image of the river and the discharge amount, the real world measured water flow as a supervision signal. So that's the model can learn actually by looking at an image, what is the amount of water flowing within this river. This is what we hope to do. Because we have seen a lot of people also relying on synthetic data that is just producing simulation images to complement a lack of data. Whenever there is a lack of data, they just refer to synthetic imagery through simulations. We can also look into coupling or like aiding, augmenting, let's say, the satellite imagery with more synthesized data from simulators. This is something that we're also preparing to look into. But this is like the main solution that we hope to implement. So the idea here is that we can have a historical satellite image of a river before a dam being built. And we can give it to our model and see that this is the discharge rate, okay? Then we can see that if you build a dam on this model, on this river, then our model will predict the reduction or what exactly will happen to the water flowing within this river. So this is what we are hoping to achieve. There is some sort of a simpler solution, perhaps, that is being suggested, that instead of looking at coupling a satellite image with a discharge rate, we can just use the river width directly from the image and use that as an indicator of the amount of water that is flowing into the river. We are not particularly sure if this would be accurate or would give us a good description of water flowing in the river, but it's a simpler solution that we are also prepared to explore. So this is overall what we have got through this week, and perhaps if you guys have any comments or questions, let's hear them out.
Thank you very much, Kamal. It's a very elaborate presentation you got going for you in the first weekend. So yeah, I think that's great. Since we are already going over time, I would refer everyone with questions to the Slack channel, so we can still ask each other all the questions we'd like, and we can still answer. But for this meeting, I would like to continue with the following group. So we have Marine Life in the schedule here, and it's presented by Divya.
I will actually present it.
Okay, that's fine.
Yeah, actually, we have switched our
oh, yeah,
task manager thing. So she will be the task manager. Yeah,
that's
thank
cool.
you. Okay, I will share my screen. So yeah, I will be presenting the introduction slides for the group Marine Life Coral. And let me start by introducing the team. So we are 6 people. Julian, who is a master's student in artificial intelligence. Divya, who is doing a PhD in satellite communication. Yes, and I'm sorry if I'm saying any name wrong. I'm doing my best. So he's doing a master in computer science, specializing in artificial intelligence and data mining. Akanksha, she's research engineer. And we have Alexio, who is also doing a master's in cognitive neuroscience, and finally myself, Mari. So I'm a design engineer for software applications at ASML. So yeah, we have people with, I feel, quite relevant experience in satellite data, machine learning, and I think also programming skills. So all this, I think, is going to be quite valuable. And yeah, I think we are going to learn a lot at this. I talk from myself. So for the next slide, for the state of the art, I will give the state to Julian. He will
Yes.
prepare the slides. So yeah.
Can you hear me well, by the way?
Yes, loud and clear.
Perfect. So I will just go very quickly over this. We chose the paper that you can see on the top as our reference paper. It's called Detection of Coral Reef Bleaching based on Sentinel-2 multi-temporal imagery. We chose this one because it's very recent. It's from this year, and they explicitly say in the conclusion that it would be very useful to implement more newer AI methods and use additional satellite data than the one that they use. They already use data from Sentinel-2, which is a couple of satellites from the Copernicus mission of the European Space Agency. So that's related to this challenge. Basically, what they did is they used that data, which is multi-spectral data, those images from coral reefs. They pre-process them, then they also use some machine learning methods for classification of every pixel. Basically, if it's a coral reef, if it's water, if that coral reef is bleached or if it's still healthy. And they got up to 88.9% of accuracy. And apart from that, they also got a lot of insight into what techniques are good or what parameters and things like that. For example, here on the right, you can see already just a graph where you can, for example, see how the different reflectance that certain types of surface can have. And then, for example, sand is very different from the rest, but you can see that healthy coral and seagrass is not that different. So, no, sorry, healthy coral and algae. Yeah, and then bleach coral is just above those. So, well, it's challenging task for classification depending on when you start introducing noise or, well, in the real world things don't work so smoothly. So, well, the main conclusions are there. Basically, they found out that the spatial resolution of the Sentinel-2 constellation of satellites is good. Also, because the revisit time, which is 5 days, is short enough. Because coral bleaching, by the way, coral bleaching is in case you don't know, when the coral reefs start dying, they turn white, and that can be seen even from space if they are big enough. And when that starts happening, in a matter of weeks, maybe they can be completely dead. So it's if the revisit time of the satellites was longer, then it might not be possible to have a fast response. But that's not the case, luckily. They also found out that it's a multi-spectral satellite, right? They have different spectral bands. They found out that band 2 is the best performing one in this case for this type of classification. And when the coral are deeper than 10 meters below the water, then, well, classification starts not working so well. So we already have some information here to start working with, and we have the queue to implement more advanced AI methods, neural networks, convolutional neural networks, for example. So, well, we have everything to get started. And apart from this is only one paper that we found. We found way more, and we have plenty of material to get inspiration from or new techniques. So we'll get into that. But yeah, this is just a short introduction to what we have in mind right now. And with that, I give the stage back to Mari.
Thanks. So just what will be the next steps that we are planning with the mind of the goal that we have in mind, which is, as Julian was saying, detection of coral reef bleaching with satellite data and artificial intelligence. To this, we want to, if we have time enough, we would like to do an early detection of this bleaching to kind of give some warning alarm for this coral reef bleaching. So the next step, and where we are already working on, is identifying which data sets that are available. So the team is working on this right now. Afterwards, depending on the data sets, we will come up with the artificial intelligence methods we can use, either supervised or supervised learning. And once we have this, we will start working on the basic model. And then the idea is that once we have this basic model, we start adding other data, other data sets from different sources, like for instance, economic parameters or environmental parameters that could affect or could actually help us in the prediction of the bleaching coral reefs. And yeah, this is the end of the presentation. If you have any question or something.
Thank you, Mari. That is a good presentation. I believe you guys are very good on the right track. Really excited about the coral topic that you're diving deeper into. So yeah, thank you. It's looking very good. And yeah, once again, for the questions, please go to the Slack channel to ask each other. And then already to the last group, the marine litter group, and we have presenting for them Giannis, if I'm correct.
Yes, I will do the presentation together with Giannis.
Okay. Totally fine. Go ahead.
Okay.
Yeah, just waiting for the slides.
Okay, can everybody see my slides?
Not yet.
No. Oh, yes, now.
Here they come.
Okay.
Yeah. Okay. So welcome to our presentation. For presenting the team, we have Apurva, he's a software engineer in India. We have Giannis, a student of computational intelligence from Greece. And I'm Isa, an industrial design student from Eindhoven. And Naman is a computer vision engineer from India.
Okay. Give me a second.
I believe we're looking at the wrong screen here, Giannis.
Yes. Can you hear me?
The face reconstruction also looks good.
Okay, but I cannot find.
Yeah, now we see the presentation.
Give me a second, please. Okay, so I was assigned with the task of finding the methods that have been applied in order to detect marine litter garbage in the sea or the coastal areas. But before that, I felt the need to explain a little more about what exactly marine litter is. So marine litter is defined as any persistent manufactured or processed solid material, discarded, disposed of, abandoned or lost in the marine and coastal environment. It's an ubiquitous phenomenon that threatens marine and coastal ecosystem worldwide. It includes any non-biodegradable item made of persistent manufactured materials, such as plastic, wood, metal, glass, rubber, clothing, and paper. Plastics which are also called synthetic polymers, are the most common type of marine litter, accounting for between 16 and 95% of the global ocean marine litter. So plastic pollution in the marine environment was first reported by scientists in the 1960s. However, did not raise public awareness and became until the last decade. And currently, policy management is being considered while plastic consumption continues to increase. And the non-fun fact now that the total mass production of plastics reached 360 million tons in 2018. And if the actual increase of production and waste management trend continues, it is estimated that about 12,000 megatons of plastic waste will be ending up in landfills or in the natural environment by 2050, which is something really, really bad. Now, who is affected by the marine litter phenomenon? Environmental impacts of plastic litter on the marine wildlife negatively influenced by biodiversity. Since it is widely interact with microorganisms to higher organisms such as seabirds and fishes, up to endangered megafauna species such as turtles through ingestion, for instance. Apart from the environmental implications, plastic pollution also presents problem to maritime traffic and can generate negative socioeconomic consequences in fisheries, tourism, or even human health. Now, where does all this plastic come from? Plastics are present in a great variety of marine ecosystems coming from both land and sea-based sources. It is broadly assumed that approximately 80% of marine litter is land-based, coming from different sources such as rivers, discharges from some water drains, and flood water events, untreated sewage, etc., or landfill loss, let's say. Nonetheless, marine pollution may also have its origin in sea-based actions such as fishing and aquaculture, illegal or accidental dumping and sea from shipping, or offshore mining and extraction activities. And now we'll talk about methods for marine litter detection till now. Traditionally, floating marine litter is detected through in situ spatial and temporal sampling surveys, where visual sensors for macroplastics or visible microplastics are used as the main technique to target litter. Although in situ methods will be always required to grant reliable information of the study area, these observations require enormous human effort, are time demanding, and remain insufficient at the global scale. In order to tackle these problems, remote sensing techniques have the potential to overtake these constraints, providing a spatio-temporal synoptic observation that can make the long-term and the global mapping of marine time more efficient than traditional in situ spatial surveys. Remote sensing platforms include satellites, aircraft, and UAVs known as drones with passive and active onboard sensors are able to target the air surface and record invaluable information as regards marine litter. Okay. Now, a little bit more about remote sensing methods for marine litter detection. All the papers that I have read so far are using Sentinel-2 images because of its high spatial resolution of 10 meters, so they are able to detect relatively big and both big and small items. It also has a small revisit time of 2 to 5 days, so we can even track the trajectory of all this marine litter garbage. And it also has a lot of bands of multi-spectral instruments, so we can use the combination of these bands in order to, let's say, create some indices and other kind of stuff. Now, based on a paper that conducts research for finding plastic patches in coastal areas using optical satellite data, and of course it's mentioned in the last slide of this representation, the floating debris index was developed, which was the key to detecting floating materials on subpixel scales. This index uses the near-infrared band of the MSI, among others bands, of course, but this band specifically reflects a big amount of electromagnetic radiation when it interacts with macroplastics and microalgae, composing the floating materials on the surface of the sea. The next step is to differentiate all this floating stuff to plastic and other objects that we do not care about, like microalgae, seaweed, woody materials, foam, etc. So we also they apply an NDVI index in order to distinguish plastics from the flora that resides in the upper layer of the sea level. The last step is to obtain the spectral signature of these two classes, the plastic class and the flora class, let's say, in order to apply supervised classification and have a better understanding of the results. A second option is to provide an automated method for detection and classification of floating materials, in which we can use a machine learning classification from the beginning, like a Bayesian algorithm, which is a training set in order to work. So it's up to us in order to, if we want to find a big data set in order to train a machine learning algorithm. And the last but not least, another paper that is also mentioned in the last slide suggests a machine learning algorithm based on a convolutional neural network that is capable of detecting and quantifying floating plastic litter. The aquatic plastic litter detection, classification and quantification system was developed and trained using very high geospatial resolution imagery, captured from area service in Cambodia. This algorithm was made of two machine learning components. First was the plastic litter detector, and secondly, the plastic litter quantifier. The plastic litter detector managed to categorize targets as water, sand, vegetation, and plastic litter with 83% of accuracy. Now the plastic litter quantifier further distinguish and enumerate the litter items in each of the classes defined as water bottles, cartons, canisters, bowls, shoes, carry bag, bags, and smaller large. That was about the methods that have been used so far, and now Apurva will introduce our ideas.
Hello everyone, am I audible?
Yes.
Yes, we can hear you.
Okay, thank you. So we've identified 3 or 4 things that we can do here. As Yanis already pointed out, so various papers have implemented different types of machine learning models to learn from the limited data set that we have of marine litter floating in the ocean. And we hope to try build our own algorithm on top of them, try something new. Another thing that we could do, since there is a very little training data set available, since we have identified very few areas of floating debris in the ocean, so maybe to increase the accuracy of our model, we could try and create synthetic images by augmenting the existing data sets that we have. Other than that, like Yanis pointed out, there are different indices used to differentiate between debris floating on the ocean surface. So we hope to try and make our own index to further make the classification of debris more accurate. And lastly, since the current satellites, they are not configured to specifically detect marine litter plastic from space, and in the future we hope to have such missions, so we would hope to identify limitations of the current sensory equipment that we have, and what should be the requirements for future missions to better detect marine litter from space. Now ESA will tell you about our future steps.
Yes, so for the future steps, first we want to decide on one main direction for the challenge and select 1 or more focus points, and then perform more research into the impact of humans on marine litter and the impact of this on the entire climate, and then perform research into where this marine litter ends up in the ocean using satellite data. And then we want to form conclusions based on the research and use this for the video. And that was the presentation.
That was it. Thank you very much for hearing
Right,
this.
thank you for presenting. You should check out the chat. Nicolas posted a link to the GitHub from ESA Lab. They also have already done some research in this field. So I believe it's very good for you guys to take a look at that. Then I believe we have had all the presentations that were or all the people who were able to present today. We have had them all. So since we're already quite a lot over time, I'm gonna let the comments part and questions part completely be left over to the Slack channel. So please, if you have any questions, make sure to post them on the channel. Also, if you don't have questions about other groups, but you and your own group can't figure out something, then also post those questions there, please. And then I believe for the action points, I'm gonna have a look at Sako then, because I believe everyone is right on track to make this challenge a big success. But as of tonight, I don't have the action points ready yet.
Yeah, so that's I think all the groups that presented their own path to walk, and so far they all seem very good. Of course, we need to pick up contact with the air quality and carbon biomass group, but that's on our side. For all of you, make sure to tune in to the masterclass, of course, next week, where Camilo will explain how to use MLReef. I heard some of you are already approaching the downloading of data and running models, so that will be very useful. And from that point, you'll also be able to use the infrastructure of MLReef. So those are up next. And I think all the groups have a clear idea of what they will be working on in the upcoming weeks. So I'd love to hear the updates next week. And for now, I'd like to thank all of you for your presentations. Really impressed by a lot of your work, decent research, and well, actually clear action points. So very well done. I'm sincerely impressed. Thank you, guys.
One more thing, the thing Sako forgot is tomorrow we already have a masterclass from the Space for Good guys. They will be presenting the GIS. So be there. It's at 7 o'clock, and I hope to see you all there. And for tonight, have a good night, guys.
Thanks, everyone.
You too.
See you guys.
Oh, bye-bye.
Bye-bye.
Bye.